All right, I'm back. We are on 306. We're going to do the second question. We already did the first one. It involved thinking about derivatives and how they relate to a function and tangent lines and all of that. And this question is going to be really similar. So find all values of x at which the tangent line to the curve y equals 2x plus 5 over x plus 2 has a y-intercept of 2. All values of x at which the tangent line has a y-intercept of 2. All right. And find the equation of the tangent lines, graph the whole scenario on your calculator in an appropriate window. Fine. All right, let's see if we can do this. So what the heck? All right, so what do we know? We know that it's going to be tangent to y equals 2x plus 5 over x plus 2. We know it's going to have a y-intercept of 2. All right, I think that what we can do here is, let's think about tangent lines, right? So a tangent line has the same slope as the curve at the point of tangency. Okay, so that's something we can use. So one way of writing the slope of the tangent line would be to just find dy dx or y prime, the derivative of that function. We also kind of know 2 points that are on the tangent line, but you may not realize that. One of them is definitely related to this, right? So if the tangent line has a y-intercept of 2, then we know that the point 0, 2 is on the tangent line. Okay, that's 1 point. Now, the tangent line intersects the curve. Every point on the curve has a particular form. Whether you want to use it or not is up to you. But because of this, we know a second point. So we actually know 2 points. 2 points on the tangent line. So the first one is 0, 2 from the y-intercept. The other point is just kind of x comma f of x. So x comma f of x, which is 2x plus 5 over x plus 2. These are 2 points on the tangent line, which means we can find the slope. We can find the slope of the tangent line 2 different ways. We can use algebra 1 slope, right? Because we know 2 points. So the algebra 1 slope would be change in y, so 2x plus 5 over x plus 2 minus 2 over change in x, which is x minus 0. Okay, woo, where are you going? We can also use calc 1 slope. Calc 1 slope, which is the first derivative. So that's going to be dy dx or y prime, whichever you prefer. Bottom, derivative of the top minus top, derivative of the bottom, all over the bottom squared. Okay, so these are both ways of writing the slope of the tangent line or the slope of the curve at that exact point, which means that these should be equal. And if they're equal, that means we now have a weird equation that we can try to solve. So we get, should I clean this up? I think I probably should. So I'm gonna get a common denominator in the numerator, which would be x plus 2. So minus 2 times x plus 2 over, so x plus 2 drops into the overall denominator and x is still in the overall denominator, so x plus 2. Still got to be good at algebra. That's like never going to go away. So that's that. It's not really fully simplified, but we can get there. And then over here, I'm going to get 2x plus 4 minus 2x minus 5. So 2x and minus 2x gone. 4 minus 5, negative 1 over x plus 2 squared. Okay, so the left-hand side, 2x plus 5 minus 2x minus 4. So this is actually just 1 over x plus 2 equals negative 1 over x plus 2 squared. So how can we solve this? Take reciprocals, move everything to one side. Let's do that. So that'll be x plus 2 equals negative quantity x plus 2 squared, but I'm going to add that to both sides. So I'm going to say plus the quantity x plus 2 squared equals 0. I'm going to take x plus 2 out of both things. That'll leave me with x plus 2. So I get x plus 2 and 2x plus 2 equals 0. All right, so from there, am I running out of space or am I just using space weirdly? Kind of running out of space. All right, so from there, let's go up here. So either x is -2 or x is -1. All right, so one of these answers can't be the answer. And the one that can't be the answer, if you think about it, is x equals -2. So this can't work because it's not in the domain. So what we're getting is we're getting only one value instead of getting two values, which so that's an extraneous solution, right? We set up an algebraic equation, we solved it correctly, hopefully, and we got one answer that doesn't make any sense in the context of the original problem, so we just kick it out. That happens all the time. That's what it means for it to be extraneous. Makes sense to the algebra, doesn't make sense to the scenario. So we get that, and then what are we trying to do? Find the, so we find, I think we found all x values, so I think this is our only x value. Then we want the equation of the tangent line. Okay, so I need to find the slope. So I'm going to say dy, let me switch to a different color here. Dy dx such that x equals -1 is -1 over the quantity, -1 plus 2 squared, which is -1. So then the tangent line is going to be, do I know the y value? I do not. Let's find y. So y such that x equals -1. It's a weird notation. You don't see that very often, but it's totally acceptable. So if I plug in -1, I get -2 plus 5 is 3 over -1 plus 2 is 1, so 3. So my tangent line, I think, is y minus 3 equals -1 x plus 1. I think that is my tangent line. All right, so now what do I want to do? I'm actually just going to use a calculator to resolve this entire problem and see how its work compares to my work. Basically, see if it agrees with my answer. So this is the problem we were doing previously. I'm going to add a new problem. So f of x is 2x plus 5 over x plus 2. Okay, so what did we do? We solved menu 3, enter. We solved, let's do this, f of x minus f of 0. What do we do? F of, oh no, we can't even do it that way. F of x minus 2 over x minus 0, because I have to use the ordered pair x f of x and 0, 2. And 0, 2 is not from the function. So it didn't make sense to try that, even though I wanted to do that. Should be equal to the derivative with respect to x of f of x, and solve that for x. Okay, -1. So the calculator knows that -2 can't be a solution. It's probably also warning you, though, that there might be more solutions that exist. Yeah, it is. Okay, but this has worked out great so far. So we get x equals -1. Let's see what f of -1 is 3, which is what we got. Let's see what the derivative. So I'm going to do a thing here. I'm going to arrow through. I'm going to hold shift as I press to the right, left, as I press to the left, and then do such that x equals -1. Might be easier for you to just type it in. Slope is -1. Let's see what the graph looks like. So we did it. We've solved the problem. All right, I want to graph f of x, and then I want to graph the line 3 minus the quantity x plus 1, which obviously you could simplify, but why do that when the calculator doesn't care? You get this, and you can see that the y-intercept is in fact at 2, and that's the whole scenario. So I think we solved it using the things that we know. So we're like building a lot of knowledge about basic calculus things. So these are all the building blocks You want to get really, really good at this, because when you're really, really good at this, the next stuff just seems like a natural extension. If you never master this, the next stuff just gets harder and harder. So it's really important that you think about these problems, try them again, see if you can come up with your own. The real issue is like, how hard is it to solve these equations? It's not really the calculus that's the hard part. Any calculus teacher will tell you the hardest part of calculus is really the algebra. The ideas of calculus are not terrible, but if you're not great at algebra, algebra 1, algebra 2, really you got to practice that stuff, because you can't get hampered by that while you're trying to solve like bigger problems. But anyway, I'm going to be back in the next video, and we're going to keep on going, and I hope you're finding these helpful, and I will see you then.